Hello everyone, this is Rashida. Welcome to my channel. My today's video is going to be on regression in TensorFlow. In my last video, we worked on a classification problem using TensorFlow, Keras, and Python. I have the link in the description box below. Please feel free to check if you haven't watched it yet. And let's dive into today's video. And again, I'm using a Google Colab notebook for this. Let's just dive in. So these are the necessary imports. I imported TensorFlow, Pandas, NumPy, matplotlib.pyplot as PLT, and then strain test split method from scikit-learn library. First thing is you need to load the data here. If you click here, it will take you to your local computer. Wherever your file is, just load your file, data file here. I'm going to use the housing dataset today. So df pd.read CSV, then housing.csv. That's going to be our dataset. df.head. This is the dataset. I have the link of the dataset in the description box below. Please feel free to download the dataset and follow along. This is quite a famous dataset available in Kaggle. You can see it has all the information like price, area, bedrooms, bathrooms, and all the other variables. Our job today is going to be use all the other variables to predict the price. So price is our target variable today. To begin with, we need to do some data cleaning. Like as you can see, this unnamed 0 column, this is clearly an unnecessary column, so I'm just going to delete that. Drop columns, then just take this. I'll just copy it from here. So, okay. The next thing is I always check the null values. So df is na.sum. This should give you the number of null values in each variable. You can see they are all zeros. So there are no null values in any column or any variable. Let's do the train test split. Train test split method from the scikit-learn library that we already imported, and you pass df. I will take the whole data frame and split it. Test size 0.2, that means 20% of the data set is going to be our test data. Random state 21. I want to separate the training features and target variable now. So train x, train dot drop columns price, then test x, test dot drop columns price. I put an underscore here. If we drop the price from the data, the rest of the features will be there, and they're all our training features. Now define the target variable. The target variable is the price column itself. So train price, and test y is again test price. Let's check the train data. If you look at it, the train data, look at this area. This area has a lot of big numbers, and the other variables, they are just smaller numbers. So this is always a good idea to normalize the data before you dive into the neural network. For that, we will need the mean and standard deviation because today we are going to use the standard normalization formula. If you don't know the standard normalization formula, don't worry about it, you will learn it now. So for that, you will need mean and standard deviation, and you can get it very easily like this. Train x dot describe. Let's see the train stats. This is how it looks like. You can see for all the variables, we have count, mean, standard deviation, mean, and all the other stuff. And we need only mean and standard deviation from this. So train stats is train stats dot transpose. So what transpose will do, you can see now for the transpose, the Row became columns and columns became rows. So all this matrix like count, mean, standard deviation, they all became the column. So you will be able to use them very easily for our standard normalization formula. Let's define the normalization function first. Normalize x, return print stats, mean, print stats, standard deviation. This is the formula. So what happens, let's say we are going to normalize the area. So what we are going to do, we will take each of these data. So let's say we will take this data. We will take this one, then deduct the mean of this whole area column and divide it the standard deviation of the area column. We will do that to each one of these data. That's how area column is going to be normalized. And we will do that with each and every variable. Let's just do it. Train X, normalize, train X. And then test X will pass through this normalize, test X. Okay, let's see how train X looks. So all the variables now have the similar kind of range. So not a single variable is overpowering anymore. The data preparation is done. So now develop the model. So model tf dot keras dot models dot sequential. Again, this is going to be sequential model, and let's build up the layers. tf dot keras dot layers dot flatten. So the first layer is, as usual, the input layer, input shape. You see the train x dot shape, and we have the 12 features. So input shape is going to be 12. And the next layer is the dense layer, tf dot keras dot layers dot. I will use 200 neurons in the first dense layer, and activation function ready. I will use one more dense layer here, tf dot keras dot layers dot dense. In this layer, I'm using 128 neurons. Activation, again, ready. I will just keep these two dense layers, and the last layer is going to be in the output layer, which is another dense layer. Dense. Because this is regression, the output layer, we need only one neuron, because for each row, for each input data, we expect only one output. And activation, as usual, ready. Remember, for the classification, we used sigmoid or softmax for the output layer because we wanted the probability output. But for regression, we don't need probability output, so the activation ready should work. Now I will just compile the model. Model.compile. First optimizer. I'm going to use keras.optimizers.atom. This is lowercase. I want to pass a learning rate. If you don't pass any learning rate, it will use the default learning rate of 0.001, but I want to pass a learning rate of 0.01. The next loss function, because this is a regression, I will use mean square error. And then matrix. Well, the matrix to evaluate the model in a regression, we cannot use accuracy. We use a loss function. So I'm going to use another loss function here. Matrix dot root mean square error. And you can see it's giving a flag in the Keras simply because we didn't import Keras. Let's feed the data to the model. Model dot feed train X train Y epochs 100. I'm going to try 100 epochs today. Let's see the model training. For an ideal model, in every epoch, the loss and metric both should go down. You can see both are going down. Now let's plot the loss. We can see we used a variable h for the model fitting. So we can use this h to actually grab the loss. The loss is actually h dot history. So you can see this loss, you have to use this. Okay, so these are the loss. You can see all the loss for all 100 epochs. Let's plot this loss against epochs. That will show you the trend. So plt.plot range 100 because we had 100 epochs. And here put the loss. And then plt.x label epochs. plt.y label. So you can see how loss kept going down and almost stabilized towards the end. So that's what we pretty much want, that our loss should really go down. In the beginning, it went down really drastically, and towards the end, it kind of stabilized in a certain position. And that's what we want for our loss. That's pretty much a very standard regression model development and training in TensorFlow, Keras, and Python. So I hope you found this video useful. Please like, comment, share, and subscribe. Thank you so much for watching.